Welcome to Spaceverse, your portal to cosmic adventures. The James Webb Telescope has made an incredible discovery, locating distant glimmers 7 trillion miles away. It has recently revealed astonishing distant lights that closely resemble the illumination of cityscapes on Earth, originating from Proxima Centauri b. Could these actually be signals from an extraterrestrial civilization? What if we are on the verge of the most significant discovery in human history? Get ready to be amazed as we delve into the hidden mysteries of Proxima Centauri b using our cutting-edge observatory, revealing the secrets of alien lights. As the telescope surveyed the vastness of space, it discovered unusual lights on Proxima Centauri b, located far beyond our solar system. These lights resemble the views of cities on Earth at night, igniting an exhilarating thought. Could there be an alien city on this distant planet? This possibility has created significant excitement among scientists, as it could signify the breakthrough they have been eagerly anticipating. It encourages us to contemplate whether intelligent life exists out there, potentially thriving in ways we have yet to conceive, and the first signs of their existence may be right in front of us. As the data streamed in, a scientist observed lights flickering at unusual intervals. Could this be a communication or merely coincidence? The team debated, with each flicker raising further questions. Meanwhile, technical issues threaten an investigative mission, leaving everyone on edge. The world holds its breath, curious if we are about to confirm that we are not alone in the universe. The discovery of these lights from such a vast distance has astonished NASA engineers, prompting them to wonder how long these signals have been shining unnoticed until our technology became advanced enough to detect them. David Kipping, an astronomer at Columbia University, has shared some intriguing insights about the fascinating complexities of Proxima Centauri b. Unlike most rocky planets that simply soak up sunlight and radiate heat, this distant world seems to dance to a different tune, thanks to its unique relationship with its star, Proxima Centauri. But here's where it gets really exciting. This discovery goes beyond merely spotting lights in the vastness of space. It highlights just how essential the James Webb Space Telescope is in our quest to understand the universe. Not only does it open the door to the possibility of life beyond Earth, but it also sparks our imagination about what life on other planets could be like. Could there be entire civilizations out there, thriving in ways we've never dreamed of? The James Webb Telescope shines in its ability to capture infrared light, which was key to unveiling the unique heat patterns on Proxima b. This is not just a technical achievement, it's a groundbreaking step for scientists trying to decipher the planet's atmosphere. Researchers are eager to dive even deeper into their studies, exploring whether Proxima b might have the right conditions to support life. What makes this telescope truly remarkable is its talent for observing Proxima Centauri b during its night cycles. While other telescopes might struggle to pick up faint lights in space, the James Webb Telescope can catch even the tiniest glimmers, making it the perfect tool to find out if there are artificial lights glowing on the dark side of this intriguing planet. It's engineered to detect artificial lights within a very specific range of frequencies, much narrower than the usual starlight. Now let's talk about the planet's captivating relationship with its star. On the side facing Proxima Centauri, solar panels might be harnessing an impressive amount of energy, and the light bouncing off these panels is something scientists are keenly observing. As Proxima b orbits its star, it experiences cycles of day and night, much like Earth. But here's the kicker. The days can get incredibly hot, while the nights turn refreshingly cool. Yet this dynamic comes with a twist. The temperature swings are extreme because the planet may not have an atmosphere. Without an atmosphere to trap heat during the night, temperatures plunge dramatically after a blistering day. These wild temperature fluctuations have captured the attention of astronomers, offering tantalizing clues about whether Proxima b might just have the atmosphere needed to support life. The telescope, equipped with advanced infrared imaging capabilities, is ideally suited for examining the heat emitted by the planet, providing us with crucial information about its atmosphere. Even more intriguing is the fact that the telescope's orbit around Earth perfectly aligns with the planet's own orbit, allowing it to closely observe the planet's day and night cycles every 11.2 Earth days. If the planet does possess an atmosphere, the next step would be to investigate its composition to determine if it could support life. Key indicators like oxygen, water vapor, and methane would strongly suggest the potential for life there. However, capturing and analyzing light from the planet's atmosphere is quite a challenging task. Fortunately, the telescope is built for this purpose, as its primary mission involves measuring components like water vapor, carbon dioxide, and methane. This data is vital for understanding the atmosphere. Although it faces difficulties in detecting bonded oxygen, an essential clue in the hunt for life, it remains vigilant, monitoring other significant elements like ozone, which can reveal a lot about whether a planet has a robust atmosphere. As scientists sift through the information collected by the telescope, their enthusiasm for uncovering the mysteries of distant planets continues to grow. Each piece of data brings us closer to answering one of the most profound questions. Is Earth the only place in the universe that harbors life? Currently, the telescope can only observe a limited number of planets that are relatively nearby. To gain a deeper understanding of these distant worlds, attention is shifting toward other advanced instruments, such as the extremely large telescope, which is anticipated to start operations by 2028. This new telescope will provide a much more detailed view of these planets, aiding scientists in determining whether they could support life. Despite its incredible contributions, the data generated is reshaping our perceptions of the universe. The insights we gain today will not only transform our understanding of the cosmos, but also influence the future of space exploration. Future space telescopes are being designed to filter out the bright light from distant stars, much like we use our hands to shield our eyes from the sun for better visibility. This advancement will allow scientists to gain a clearer view of the faint reflections from planets and analyze their atmospheres to determine if they could potentially support life. However, distinguishing whether the gases present in a planet's atmosphere are produced by living organisms or natural phenomena such as volcanic activity poses a significant challenge. With these fascinating findings laying the groundwork, we now shift our focus to how they will influence our future endeavors into the cosmos. The role of James Webb in finding life beyond Earth. Researchers are diligently enhancing their techniques for differentiating between these signals, which will facilitate the identification of genuine signs of life. This quest is not solely about discovering life, it's also about expanding our knowledge of these distant worlds. Currently, the James Webb Space Telescope is providing us with early insights into what future explorations might reveal. Each new finding stretches the limits of our understanding and helps us better comprehend our role in the universe. Since the dawn of humanity, we've wondered if we are alone in the universe. Today, this telescope is actively scanning various areas of the sky, seeking signs of life beyond our planet. The notion that extraterrestrial life could exist is gaining wider acceptance, and scientists are working tirelessly to gather evidence. In 1984, American astronomers Jill Tarter and Thomas Pearson launched the search for extraterrestrial intelligence, establishing a nonprofit organization dedicated to detecting radio signals from space using the Allen Telescope Array's 42 dishes located in the mountains of California. These signals can traverse vast distances with minimal interference, making them invaluable in the search for life. For more than 30 years, SETI has been on the lookout for signals from alien civilizations, yet it has yet to identify any clear indications. Despite this, Jill Tarter remains optimistic. She believes that, with today's advanced technology, we are closer than ever to a significant breakthrough. Tarter hopes that this mission will evolve into a global initiative, uniting people in the common goal of discovering life beyond Earth. Recently, a new NASA report has sparked excitement in the scientific community, suggesting that the telescope might have captured something extraordinary, what appears to be city lights on a distant planet. Located 1 million miles from Earth, this telescope enables us to delve into the mysteries of the universe like never before, unveiling details that were previously beyond our grasp. Its design focuses on discovering phenomena we couldn't observe before, aiding scientists in understanding the formation of galaxies, stars, and planets. With its advanced camera and specialized filters, astronomers can now analyze the colors surrounding distant celestial bodies in greater detail. These tools allow them to investigate the physical and chemical compositions of planets and stars by examining different wavelengths of light. But the telescope doesn't just observe, it also investigates the atmospheres of other planets for potential signs of life. Its unparalleled capacity to probe the depths of space and time has led to groundbreaking discoveries, including the revelation that large galaxies contain far more mass than scientists initially believed. This finding has prompted a re-evaluation of theories regarding the universe's origins and its ongoing expansion. Each new discovery from the telescope fuels our fascination with alien worlds and enhances our understanding of the potential for life beyond our planet. As we push the boundaries of space exploration, we gain fresh insights into distant realms, but this also raises more profound questions. Around 20 years ago, the expanse beyond our solar system was largely uncharted, with minimal information about planets orbiting other stars. Fast forward to today, and astronomers have identified over 4,000 exoplanets, highlighting just how far we've advanced in both curiosity and technology. NASA, a frontrunner in space exploration, believes this is merely the beginning, estimating that our galaxy alone could host trillions of planets, each harboring its own mysteries. The quest to explore space and uncover what lies beyond continues, and scientists remain vigilant in their search for any signs of life beyond Earth, sometimes coming remarkably close to finding them. A pivotal moment occurred when the Galileo spacecraft orbiting Jupiter discovered evidence hinting at possible plant life on a distant planet. This groundbreaking find included a biosignature known as the vegetation red edge, which detects plants based on their light reflection. Inspired by this, the telescope aims to delve deeper into space to identify planets within the habitable zone, where conditions may support life. New tools, like the virtual reality engine, are set to revolutionize our search for planets that could harbor not only simple life forms, but also intelligent ones. This new phase of exploration focuses on understanding the vast unknowns of the universe. As sunlight filters through distant planet atmospheres, it creates unique patterns called spectral signatures, akin to cosmic fingerprints that reveal clues about the potential for life. Scientists believe the telescope will capture light passing through a planet's atmosphere when it transits in front of its star. This could reveal the atmospheric composition of Earth-sized planets, typically rich in carbon dioxide, nitrogen, and oxygen. Unusual chemicals could indicate alternative forms of life or advanced civilizations. For instance, detecting chlorofluorocarbons could suggest intelligent life on another planet. Such discoveries would open new avenues for astronomers, enabling them to explore the atmospheres of planets and the potential for life beyond our galaxy. As we continue this journey, the next section will explore how these technological advancements could reshape our future explorations. Life in extreme cosmic conditions. When we contemplate life beyond Earth, we encounter a multitude of possibilities that may be vastly different from our own. While we often envision life thriving in mild, stable environments, the reality may be far more diverse. Consider extremophiles, tiny organisms that redefine our understanding of where life can exist. These remarkable creatures can survive in extreme conditions, such as temperatures exceeding 250 degrees Fahrenheit or environments with a pH as low as 3. Their ability to flourish in such harsh settings illustrates the incredible adaptability of life, even in places we typically consider uninhabitable. Yet, this is only the beginning. As we continue our quest to find planets that could support life, discovering it in these unexpected environments could revolutionize our perception of the universe. We are just beginning to grasp the full range of possibilities. Space exploration is a vast field with many avenues to explore, so our search for extraterrestrial life must be both comprehensive and inclusive. While planets like Earth orbiting stars similar to our Sun are excellent starting points, we must also remain open to exploring less conventional locations. For example, exoplanets, those outside our solar system that orbit red dwarf stars, present intriguing prospects. Although these stars are less bright and warm than our Sun, they create unique conditions that could still foster life. Additionally, red dwarfs have significantly longer lifespans than stars like our Sun, providing ample time for life to evolve. A prime example is the TRAPPIST-1 system, which features a dim red dwarf star and 7 rocky planets orbiting it, 3 of which reside in the habitable zone. This zone suggests the potential presence of liquid water, a critical element for life as we know it. Although the TRAPPIST-1 star is smaller and cooler than our Sun, it emits enough light to potentially support life. Scientists are studying this light to learn more about what living on these planets might be like. Thanks to the James Webb Space Telescope, we know the system is about 41 light-years away in the constellation Leo, making it an exciting area for exploration. NASA scientist Ward Howard, leading a research team from the University of Colorado, Boulder, is thrilled about these discoveries, highlighting how JWST allows us to study planets with atmospheres similar to Earth's. Understanding stars helps us infer what their surrounding planets might be like. However, TRAPPIST-1 isn't the only noteworthy star. Proxima Centauri is our closest stellar neighbor, only about 4.25 light-years away. While it's dim and hard to see from Earth, any planet that could support life would need to be much closer to it. In August 2016, astronomers discovered Proxima b, a planet about one-third larger than Earth located in the habitable zone of Proxima Centauri. This zone receives just enough sunlight to melt ice and create conditions suitable for life. Proxima b orbits its dim star at just 4.6 million miles away, facing significant environmental challenges such as strong solar winds that could erode its atmosphere. Despite these issues, the planet receives enough light to keep its surface warm, potentially allowing oceans of liquid water to exist. However, it is tidally locked, meaning one side is always in sunlight while the other remains in darkness, creating two distinct environments. This situation is akin to the Moon's constant face toward Earth. Although Proxima Centauri is smaller, it still provides enough energy for life to possibly thrive, perhaps in ways similar to life on Earth. Did the James Webb Space Telescope really find evidence of alien civilizations? Or are we just seeing what we want to believe? Share your thoughts below. And that's it. Thanks for joining us at Spaceverse. Today, we dove into the exciting search for life beyond Earth, exploring the findings of the James Webb Space Telescope and the intriguing worlds of the TRAPPIST-1 system and Proxima b. If you enjoyed our cosmic journey, please like, subscribe, and share your thoughts below. Until next time, keep looking up and dreaming big.